Okay, so theorem is to find distance of a point from a line. Now this is a vector distance of a point from a line, and we will be calculating the distance using our vector notation. So what we have a line. Let me take a different color. So let's suppose we are given a line, and to define a line in a vector we need a point. So let's suppose this is a point a bar and some parallel vector, let's say p bar. And now we are given a point P which has a coordinate, let's say alpha bar, and we need to calculate the distance. So distance is nothing but a perpendicular distance from that point. So let's suppose this is a perpendicular distance. The foot of this point is M. Now we'll do one construction, that is to draw a line from A to P. Let's see how this will help us. So what do we know? We know that this line is represented by R bar, which is equals to A bar plus lambda B bar. Here lambda is a scalar quantity. Great, so this information we have. Now what we can do from here? We see that this AP is this AM is nothing but projection of AP on this line P, right, or B bar. So what we can say that AM bar is projection of AP on B. And how we write projection? So we can say this is nothing but AM bar is nothing but AP bar, and since we need to show that it's projection of AP, we just take a unit vector along the B direction. So how we'll get the unit vector? We'll take the vector B and divide by its magnitude. So we'll get AM bar is nothing but AP bar into B bar upon magnitude of B bar. So now we know what is the value of AM bar. We can see here that triangle AMP is a 90-degree triangle, and we need what? We need value of PM. We need value of PM. So how we can calculate value of PM? By using Pythagoras, of course. So let's apply Pythagoras to this triangle, and applying Pythagoras, what we can say? Value of PM, that is PM square, is equals to hypotenuse, which is AP, so AP square, minus the other side square, which is AM square. So now we need PM square, we know AP square, we know AM square. What is the value of AP square? AP square is nothing but alpha minus A. AP is nothing but alpha minus A. So we can say this is alpha minus A magnitude, and we need its square. Similarly, what is AM? AM we have already calculated, which is AP times B bar over magnitude of B bar. And what is AP bar? AP bar we already see here. So we can say alpha minus A bar square minus what is AP? So AP is alpha minus A, and since we are taking a dot product, we will not take its magnitude but we will take its vector, and we will take a dot product with B bar divided by, we'll have our square here. So again we can put a square here. So this is our formula, but we need PM. So what we'll do, we'll just take square root. So we'll have PM as square root of alpha minus A square, that is alpha bar minus A bar square, minus alpha bar minus A bar times B bar over magnitude of B bar whole square. So that's our formula, and this formula is nothing but just a Pythagoras. It's just a Pythagoras. So what we need to remember, we are applying Pythagoras to this triangle, and we know all the values. So Pythagoras, we are calculating PM, and PM bar square is nothing but AP bar square minus AM bar square, and since we need value, so we'll take the magnitude of this, and this is our answer. So we just need to remember this, and from this we can easily get this value.